Example 4, solve the system of equations. Okay, again, we're going to use the echelon method. So the key to echelon method is that triangle. We want to produce triangular form. Now, this one, you notice a couple of things make it harder. It's 3 equations with 3 variables. But also, you notice when I draw that triangle, I've got 3 different variables outside of the triangle. Everything that's outside of the triangle, you have to get rid of. You have to eliminate. Okay? So that means we're going to need 3 separate rules and get rid of those 3 separate variables to produce our triangle. Okay? It's kind of confusing. People trip over themselves and trip over the math because they're not very good at at negative numbers. So by all means, use a calculator if you want. Okay, calculator can really make this easy, I suppose. So the key is, if you're going to get rid of this variable, you have to use this term right here. You have to use something inside the triangle to get rid of something outside the triangle. All right, specifically the one along the diagonal of the triangle is the one you have to use. Okay, so think about the LCM of the 2 coefficients. The LCM of 2 and 1 is 2. So we're going to need a statement that says 2 minus 2 or negative 2 plus 2. Either way, it's something that makes 0. Okay? So one way to do it is if you said 2 of the row 2's minus row 1. 2 row 2's minus row 1. That would give me 2x minus 2x, correct? You might have picked a different way, but it has to give you 2x minus 2x is 0. Whatever you pick, it has to produce 0 there. Okay. Top row stays the same. 2x plus y minus z equals 2. Middle row there. Okay. So we're going to go 2 of these is 2x minus this. That'd be 2x minus 2x is 0x. So again, if you want to leave that blank, leave it blank. Okay. Moving on to the y terms. 2 of the row 2 numbers is going to be 6y minus this row 1 number. That's going to be 6y minus y is plus 5y. And then we're going to do 2 of these z. So 2 of the 2 z's is 4z minus negative z. So be very careful. You've got 4z minus negative z. So that's 4z plus z is plus 5z. And then 2 of these is 2 minus this. That's 2 minus 2 is 0. That's supposed to be a plus. Okay. Now, since I also have to get rid of this term, oh my gosh, my pen doesn't work. I'm going to do another rule, but I still have to use this term right here. Okay. Really, it's the same thing because you've got an x and you've got a 2x, so we can use the same kind of rule. 2 minus 2 gives me 0, but you just have to make sure you're using the row 3. So 2 row 3 minus row 1. That'll give me 2 minus 2. So 2 of these is 2x minus this. 2x minus 2x gives me 0x. And 2 of these is 2y minus the row 1. You'd have 2y minus y is plus y. And 2 of these is 2z minus negative z. 2z minus negative z is plus 3z. Did I mess up?
No, I have a question.
Okay.
How do you know whether to use row 1 or row 2?
How do I know whether to use row 1 or row 2?
Or when you're writing the rule?
Well, you're going to have, whatever one you're looking at, you definitely have to look at that. So here in green, I'm definitely using row 3. But then, and you'll see as we go on, you have to use the number that's on the diagonal of the triangle. So sometimes it would be easier. You're probably thinking, well, why don't I just go row 3 minus row 2 and get 0? That'll work sometimes, but other times that will lead you backwards, okay? So in this case, that would work. If you were thinking, why didn't I just do row 3 minus row 2? But I remember being in your shoes, and I had that same exact thought, and it worked often enough to make me want to do it, but then there were other times, and you'll see it later, that it led me backwards, and I was confused why it didn't work this time. So it works sometimes. If you're careful, yes, you can do that, okay? But if you'll always use the one on the diagonal, it will always work. What you're saying will work sometimes, okay? So here, this last number, we've got 2 of these. That's a great question, by the way. 2 of these is 4 minus, oops, got to go row 1, right? 2 of these is 4 minus this 2 will give me 2. Okay. Notice the triangle. We don't really need these right here, right? Okay. But we still have that y outside the triangle. And so we have to do another rule to get rid of that y outside of the triangle. Okay? Now, go back to your question. If you were going to try to do this one using this one, if you just wanted to say y minus y, that would produce a 0 where you want, but the problem is this 2x right here is going to come down and pollute your emptiness outside of the triangle, okay? So you've got to avoid that. You can't use the y minus y because it's going to bring an extra x down where you don't want it. We already eliminated x. We don't want to uneliminate the x, okay? If that makes sense. So to be safe, we're going to use this one basically because we've already eliminated the spot next to it, okay? So we want to eliminate this y using that 5y. So think about an LCM. LCM of 1 and 5 is 5. I'm going to need a rule that says 5 minus 5. So once you get the hang of it, it would become clear that we're going to do 5 row 3s minus row 2. 5 row 3s minus row 2. Okay. So the top row can stay the same. 2x plus y minus z equals 2. The middle row, actually, I'm going to use one of the other row operations. One of the row operations says that you're allowed to multiply by a number. So I'm going to take row 2 times 1/5. You're probably going to think of it as divide by 5. Okay? If you divide everything by 5 or multiply by 1/5, same thing. You would get y plus z equals 0. That'll just make it easier to finish later. Okay? You don't need to do that, but it reduces your equation down, makes it a little bit easier. Okay, now I'm going to use my rule. 5r3 minus r2. So 5 of these, oops. 5 of these is 5y minus this will give me 0y. And again, you can leave that blank. 5 of these is 15z minus row 2 would give me 5z. 15z minus 5z is plus 10z. And 5 of these is 10 minus this. 10 minus 0 is 10. Okay. So again, what I'm going to be looking for is this triangle. If I don't see this triangle in your work, I don't believe that you did echelon form. Okay, we've got the triangle. Now we're going to use back substitution. Well, you can see that z equals 1 down there at the bottom, right? Z equals 1. Divide by 10, z equals 1. We're going to substitute that in. So you'd have y plus 1 equals 0. subtract the 1 over, and now we know y equals -1. And now we're going to take both of those numbers and plug them into the top. Back substitution. We're going backwards. Okay? So we can plug both of those numbers in. This is z, and this one is y. So I'm going to come over here. You have 2x minus 1 was y, minus 1 was z, equals 2. 2x minus 2 equals 2. Add the 2 over, 2x equals 4. Divide by 2, x equals 2. So you've got one solution, 2, comma, -1, comma, 1. Let me make that look more like a 2. 2, comma, -1, comma, 1. I know you have other methods for solving systems of equations, but this is the echelon method. Okay? Make that triangular form, use back substitution.